My name is Mohammad Saeed Zafar. I am doing PhD in Civil Engineering at University of Mexico, Department of Civil Engineering. My research is basically focused on 3D concrete printing. So if we talk about 3D concrete printing or additive manufacturing in field of metals and plastic, it's at very advanced stage for now. But about if we talk about the concrete printing, it's still at developing stage. So there are a lot of challenges and gaps that we need to address, and in my research in PhD, I am focusing on some of those challenges.
Okay, so for most of them is in
Concrete by itself doesn't show any tensile property. So it means if you have a piece of concrete and if you start pulling the concrete apart, it can easily break. It's very brittle material. So for the buildings, they are exposed to different types of load. It could be lateral, similar to earthquake or wind. So the material should hold and resist both tension and compression. Concrete is a great material for compression, but when it comes to tension, it's a big material. In order to use concrete in the construction, even in the conventional construction, we need to reinforce this material with steel reinforcement or some other strategy that we can use. When it comes to the 3D printing, if we want to use the similar strategy to reinforce the material, it could change the level of automation that we have in the printing process that the technology is offering us.
Basically, the basic purpose of doing this work was to address the problem of reinforcement in 3D concrete printing. We are claiming that the 3D concrete printing is totally automated process. That's why we wanted to develop ultra-high ductile material, because in that material, we are just using fibers, high content of fibers. We include the fiber during the mixing process. And if we can successfully design ultra-high ductile material without using conventional steel bars, that can solve the problem of the incompatibility of reinforcement with 3D printing process. The whole research is basically funded by Transit.
Transit is Region 6 University Transportation Center, and they supported this project for 2 years, from the very first stage to develop the mix, to make it printable, and then characterize it and study that in terms of mechanical and fresh property for 3D printing.
So when we did the printing trial, we came up that printing quality in terms of extrudability and buildability was not very satisfying because of high content of fiber that we use. So we have to fix those printability issue. So to do that, we came up using different viscosity modifying admixtures to fix this problem of printability, and we successfully did that.
The material by itself doesn't show good printability properties, so we did comprehensive research on how we can improve the quality of printed filament. The material that Saeed developed for his research is a bendable concrete. So this bendable material has some ultra tensile capacity. It means because of the incorporation of large quantity of fibers, very fine fibers in this material, it could hold all of the concrete together when it's subjected to any sort of bending or tension load. If we're going to use this material in larger scale, we don't need to add reinforcement, external reinforcement to the concrete structure which is printed.
So for the mechanical performance, we did two main type of tests. One is to access the flexural capacity of the printed specimens. We use a printed prism. So you can see we get enough flexural capacity. The stress strain response was quite good. And the second test we did is using dog bone specimen, and the test is direct tensile test to test the property of ultra-high ductile cementitious material in tension.
The strain capacity was very high compared to the previous work which has been done in this area for the cast material. It's even above that, and it was very successful research. This material has 3D printing property and very high structural viability that could be used in the construction industry.